Hi there, Mr. Sutton here with the Pre-Cal Honors 9-5 Part 1 homework solutions on limits at infinity. To find the limit as x approaches negative infinity on this polynomial, we're just going to ignore all the slower growing terms. So I can write this as limit as x approaches negative infinity of just x cubed. All these slower ones become insignificant as we go to infinity. And with just one x left, I'll just go ahead and plug in negative infinity. So this is negative infinity cubed essentially. Which basically we have a negative to the third power, so that's going to come out negative, and the rest of this is just infinity, so we have negative infinity when all is said and done, or dne. For this problem, to find the limit as x approaches infinity, we're going to choose our champion and ignore the slower growing terms on each side of this fraction. So in the numerator, we can ignore this 3, which grows slower than the negative 2x to the fourth. Denominator, we're just going to use the x as our champion here. The plus 2, insignificant as x goes to infinity. And then we'll reduce this. This is really negative 2x cubed. Still have that limit hanging around. And at this point, we'll plug infinity in. So this is negative 2 times infinity cubed. Infinity cubed is just infinity. Multiplying that by negative 2, though, makes this negative infinity. For this problem, to figure out the limit as x approaches negative infinity, we're going to choose our champion on each side of this fraction. In the numerator, we ignore the slower growing negative 2x, so it's just 4x squared. In the denominator, only 3x cubed needs to hang around. And let's go ahead and reduce this. This is going to be 4 over 3x. And now we can plug negative infinity in. So doing that, we end up with negative infinity in the denominator. Since we have a constant in the numerator, a constant over an infinity always gives us 0. To find the limit on this problem, since we're going to infinity, we ignore the slower growing terms on each side of the fraction. So in the numerator, we just have the 5x squared that we're considering. Denominator, we consider only the 3x squared, so choose your champion on each side. X squareds can cancel out, so this really just comes out to 5/3. On this problem, we want to know which of the following has a value, a limit value of negative 1. So this is going to take a little bit of work. We have to go through each of these and actually find the limit. Taking a look at this first one, this absolute value function, the trick on this one is to turn it into a piecewise function. So piecewise function, here we go. My border value is going to be 0 because that's where the absolute value changes its behavior. So we have a rule for what happens when x is less than 0 and a rule for when x is greater than 0. So when x is less than 0, the stuff inside absolute value is negative. So to simulate making that positive, I'm going to write negative x over x. And now if x is greater than 0, well, the stuff inside here is coming out positive anyway, so I can just drop that absolute value and make it x over x. Now, in order to actually plug in 0 here, I need to first reduce these. Otherwise, I'm just getting 0 over 0. So my top rule reduces to negative 1. Bottom rule is positive 1. And now I just wanted the left side limit out of this. My left side limit is going to be this before rule here for x less than 0. So that's going to be negative 1. So it turns out option 1 is correct. So that eliminates at least choice C. But now we have to take a look at options 2 and 3. So for option 2, for this one, you could start by plugging in 3, but I can see right away that this is factorable. So my numerator, that can factor into x minus 3 and x minus 4, things that multiply to 12 and add up to negative 7. And my denominator, I'll just factor out a negative 1, so negative 1 times x minus 3 for that. And the nice thing here is that these x minus 3's cancel. That would have given me 0 over 0 if I had just plugged 3 in right away. But now that I've canceled them, plugging in negative 3 gives me 3 minus 4 over negative 1. So that's going to be negative 1 over negative 1, which is positive 1. But we wanted a limit of negative 1. So option 2 does not actually work. So now it's down to either 1 only or 1 and 3. It all comes down to this last one. Since we're approaching infinity on this one, that means we can disregard the slower growing terms, the constants in this case, and just think of this as limit as x approaches infinity of negative x over x. We can reduce that to just negative 1. So it turns out options 1 and 3 both work. Choice B. On this one, we're trying to figure out the limit as x approaches infinity of this rational radical function. So because we're approaching infinity, we're allowed to ignore slower growing terms in the numerator and denominator, so basically choose your champion. In the numerator, we have just the square root of 9x to the fourth that we have to consider. This plus 1 becomes insignificant as x goes to infinity. In the denominator, we're only going to consider the 4x squared. And now, moving this forward here, we can actually square root that stuff in the numerator to get 3x squared. And it looks like we can cancel out these x squareds as well. So when all is said and done, this limit's just going to come out to 3/4, which is choice B. For number 7, we have an infinite limit on this fraction, so we can just pick our champion. On the top, there aren't a whole lot of choices. On the bottom, though, we'll just use n squared. So reducing that, we just have 4, which gives us an answer of D. For 8, we have the limit as x approaches infinity of this fraction. Now, the key to doing the whole choose your champion technique is you have to have things in standard form. So after you multiply all of this stuff out on both sides, that's when you pick your fastest growing function. Now, up here, if we do 2x times negative x, that negative 2x squared is going to be the fastest thing we can possibly get up there. Down here, it's going to be the x times the x squared. So reducing this, then, we've got negative 2, and that's our final answer, choice B. For this problem, we're trying to find the limit at infinity for this rational expression. So for this one, since we're going to infinity, we can drop all the slower growing terms in the numerator and the denominator. So in the numerator, choosing our champion here, we just have x cubed remaining. And in the denominator, we will just consider 4x cubed. So now that we have it set up like this, we can just cancel out the x cubes, leaving us with 1/4, choice C. On this problem, we want the limit as n approaches infinity of this rational function. Now, since n is approaching infinity, that means that I'm allowed to ignore slower growing terms. So choosing my champion here, in my numerator, I just have 3n cubed, and in the denominator, just n cubed that I'm going to consider. And now I notice that these are really the same thing, except the top has a 3 in front of it, so I'm just going to cancel those and reduce this to 3, which gives us answer choice D.